And for your powers chart, you will have to have these numbers memorized so you can recognize them quickly. We won't do our powers of 1. I hope you know that 1 squared is 1. 1 to the power 4 is 1. 1 to the 5, 1. So we won't do 1s. That's a white line. Here we go. But we will start with 2. And down here we'll do 2 to the power 1. We won't do anything to the power 0 because you know all the power zeros are 1. We could probably skip 1 as well. Powers of 2. Well, 2 to the 1 is 2. 2 squared is 4. 2 cubed is 8. 2 to the 4 is 16. And they're just doubling each time. So the powers of 2, without your calculator, you can always figure them out by just doubling along the way. And you could keep going. Where do you see the powers of 2? Often in everyday life. Seen those numbers before? 8, 16, 32, 64. What's that? Megabytes. If you think about, or gigabytes, you're buying a flash drive. You can never buy a flash drive that's not one of these numbers. They don't exist. You always buy an 8, and the next size is a 16. And then the next size is a 32. Because that's always powers of 2 when they make sizes for computers. Used to be my first computer. Our first computers had 32 megabytes of memory. It's like, wow, that's amazing. And then there was ones that came out like the Commodore 64. Lots of power. And then there's people playing the 2048 game now. And they're all powers of 2 when you put the numbers together. Okay, so there's our powers of 2. Powers of 3. 3 squared is 9. 3 cubed is 27. 3 to the 4 is 81. And after 3 to the 4, that is about as high as you would need to go without your calculator and be able to recognize it. 3 to the power 5, you could multiply this through. It's not too bad to get 243. But you will be expected to be able to recognize up to 81. When you see that number, you go, I know that that's a power of 3 without my calculator. Powers of 4. 4 to the 1 is 4. 4 squared is 16. 4 cubed is 64. And 4 to the 4 is 256. Most likely, without your calculator, they'll expect you to be able to recognize up to 4 cubed. So the powers chart isn't so bad for having it memorized because mental math, once you get to 4, since the numbers get so big so quick, you only have to know up to cubes. Same thing with 5. 5 squared is 25. 5 cubed is 125. 5 to the 4 is 625, but that would be as much as you'd be expected to know without your calculator. And now we can, once you get to 6, we have 6 and 36. That is where they'd expect you to know. After 6, just knowing the squared ones. If we do 6 cubed, it's 216. So same thing with 7, 8, and 9. You're going to need to know what they are squared, but nothing really beyond that. So there's your powers chart. You have to have it memorized because when you see a number like 64, 64 is a good number, you have to know 64 is 8 squared. You have to know that 64 is 4 cubed and 64 is 2 to the power 6. And then you have to decide which one of those powers is the best to represent it. Because if I have a 64, I can change it and write it as 2 to the power 6. and that could help me solve it. Just like the question in the above in the construct the understanding, when we had 2 to the x equals 32, you may have been guessing and checking till you found one that worked, but now if we have our powers chart, we can say, oh, 32 is a power of 2, and I can write it as 2 to the 5. And if I write both sides as powers of 2, it becomes obvious that if I have 2 to the power something equals 2 to the power something, and those things are equal, then both those numbers in the red box have to be equal. That's the only way that equation can be equal. And then you could say to yourself, well, I know that x has to be 5. And that's what we're going to do in our first examples. So we'll go to example 1.